In this video, we'll be going over the math behind a piston-driven positive displacement pump, our pump being a syringe. We have a syringe filled with 30 milliliters of water. The syringe is connected to a hose. We compress the syringe until it is at the 21 milliliter mark, and this happens over the course of 3 seconds. This completely fills the hose attached to the syringe. I have collected the measurement for the syringe internal diameter, which is 24.59 millimeters, and the length of the compression, which is 20.92 millimeters. The hose the fluid is running through has an internal diameter of 4.77 millimeters and a length of 525 millimeters. We want to find the flow rates and velocity of the fluid going through the syringe and small tube. I'll be solving this for the values multiple ways to show how everything lines up. This problem works off the concept of conservation of volume of an uncompressible fluid. Tangent: water is slightly compressible, but for our case it virtually is not. Looking at the diagram, if we take the 30 milliliters initial state, which we will label 1, and subtract 21 milliliters final state, which we will call state 2, we get 9 millimeters of fluid in the tubing. 9 milliliters divided by the time to fill the hose of 3 seconds equals 3 milliliters per second for our flow rate. The second way we can find this value is by finding the volume of the cylinder of the syringe displacement and the volume of the cylinder of the hose, because it is completely filled after 3 seconds. Volume is conserved, so we can set the two volumes, volume 1 and volume 2, equal to one another. Recall that the volume of a cylinder is the area of a circle that makes up the end times the height, or in this case, the length of the cylinder. Plugging in our numbers, we get the displayed values, which are fairly close but differ due to the experimental error or manufacturer variances. They both are around 9 milliliters of fluid. Now to get the volumetric flow from either of these values, we can once again divide by the time of 3 seconds. We get values that are close to the theoretical value of 3 milliliters per second, but vary slightly due to experimental error. Now to get the velocity of the water in the hose, we can take the total length of the hose and divide by 3 seconds, which gives us a velocity of the water of 175 millimeters per second. Or let's say we only have the length of the compression of the syringe and the internal diameter of the syringe and the internal diameter of the hose. Because in theory, volume 1 should equal volume 2, we can set the volume equations equal to one another and solve for length 2. We can cancel out the pi divided by 4 because it is on each side of the equation. The formula now is the internal diameter of the syringe squared times the length of the displacement of the syringe divided by the internal diameter of the hose squared. Plugging in our numbers, we get 556 millimeters for the length of the hose. Now we can divide that by 3 seconds and we get a velocity of 185.3 millimeters per second, which you can use an internet converter if you want to convert to a different unit of velocity. Now let's say you were given a velocity of the water going through the hose, which we will be using 175 millimeters per second, and we are trying to find the velocity of the syringe compression. Well, we could once again divide the syringe displacement by 3 seconds, which equals 6.97 millimeters per second, or we could use the principle that flow rate 1 equals flow rate 2, and plug in the velocity as the length of a cylinder that makes the flow rate 2. Doing so, and rearranging the formula, we get a similar equation to what we found before. We get internal diameter of the hose squared times the velocity of the water going through the hose divided by the internal diameter of the syringe squared. Plugging in our numbers, we get a value of 6.59 millimeters per second, which varies slightly, mostly due to the experimental error. That concludes this video. Hope you'll have earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Let me know how I'm doing in the comments down below. Thank you for watching.